Hello everyone. Today's model question is regarding the shape of the earth. The shape of the earth is more similar to that of an orange. It's more compressed over the poles and it's bulged over the equator. Now, have you ever wondered why the earth's shape is like this? And this model question is regarding the reason behind this peculiar shape of the earth. Like, why it is flattened at the poles and why it's bulged at the equator. If we measure the length of the earth on a line passing through the equator as well as another line passing through the poles, right? If the earth were a perfect sphere, both of this length would have been same. But in the case of earth, this distance, they are different, right? The length, the distance passing through the equator as well as the distance passing through the poles, they are different. And for this reason, right, we can understand that the shape of the earth is compressed over the poles as well as it's bulged over the equator, because this length passing through the equator is greater than that of the length passing through the poles, right? So the shape of the earth is called as oblate spheroid. A spheroid means it should be a perfect sphere, but earth is not a perfect sphere, and for that reason we call it as oblate spheroid. The earth is having two kinds of movement, one revolution around the sun and the other one like the rotation on its own axis, right? And this rotational effect is felt differently at different latitudes. For example, an object there on the equator is traveling with more velocity than another object there in the higher latitude, right? So the rotational effect of the earth is more felt over the equator than other latitudes. I don't mean to say that the earth is rotating separately, rather than they are rotating together, all the latitudes they are rotating together, but the rotational effect felt over the surface is different with, if you are considering different latitudes. Like in the North Pole as well as the South Pole, right? The rotation is 0. And in the equator, it is maximum. Okay. Now for this reason, right, since the rotational effect is more over the equator, we'll be having more centrifugal force affecting the equator. Now centrifugal force in the sense, imagine you are tying a stone at one end of a thread and at the other end of the thread, you are holding and you are spinning it, right? So why? You are applying a force to this stone, but yet it is not hitting your hand, right? What if you loosen this thread, right? In the sense, this stone will fly past you, right? It won't hit your hand, but it will move away from your hand. Now why it is so? Now the force behind this movement, right, away from the hand is because of the centrifugal force, right? When the same way, right, like applying to this rotation of the earth, if the earth is rotating, right, the materials inside the earth will be having a tendency to escape this rotation. Now this tendency to escape the rotation is more over the equator than over the polar regions or high latitude region. The reason be here, because the earth is rotating with more velocity over the equator. For that reason, the centrifugal force will be more over the equator than the other latitudes. And because of this reason, right, the materials, they will try to escape through the equator, and that's why the shape of the earth is bulged over the equator and they are relatively flattened over the polar regions, right? Now let's go back to the question. So the question is asking you the reason behind this particular shape of the earth, why it is flattened over the poles and why it's bulged over the equator, right? Going through the options, rotational motion of the earth, which we have already seen, like the rotational motion of the earth is the reason why the earth is flattened at the poles and they are bulged at the equator, right? And the second option given here is tidal force. Now tidal force denotes the gravitational attraction of moon as well as sun. Okay. Now the gravitational attraction of moon and sun, they are relatively negligible force when comparing with this centrifugal force. And the tidal force won't be able to create this bulge over the equator because it's a negligible force, right? Since we already understood the first statement is correct and the second statement is wrong, going through the options, right? You can eliminate all the options without one so that you can eliminate B as well as C. And what left is A and D, right? So if any one of the second statement or third statement is wrong, the answer would be A, right? So since we already understood the second statement, which is tidal force, cannot create the bulge, right? Being it a negligible force, it cannot create the bulge. For that reason, we can eliminate D and the answer straight away comes out as A, right? Now again going through the third statement, greater insulation received over the equator. Now this statement separately is a correct statement, but thinking it from the perspective of the question, the greater insulation received over the equator cannot create this bulge over the equator because it is again a negligible force. The expansion resulting from the greater insulation cannot create the bulge. For that reason, right, here the answer comes out as A, which is 1 only. So why the shape of the earth is flattened at the poles and bulges at the equator? The answer is rotational motion of the earth.